We need to obtain a geometric progression with some conditions that the sum of the first two terms is -4 and the third term is a quarter of the fifth term. So let's begin. First, we'll need to specify the first term and the common ratio. So let the first term be represented by the letter A in lowercase, and the common ratio is also going to be represented by a lowercase letter. So let it be R. Now it's given here that the sum of the first term, which is A, and the second term, so that will be A times R, that the sum is equals to -4. And it's given here. And the next condition is that the third term, A3, that's equals to a quarter of the fifth term. Or in other words, we can write A5, which is the fifth term, is equals to 4 times the third term. So using the general nth formula for finding the term of a geometric progression, which is given by A times R raised to the power of n minus 1. So the fifth term will be A R raised to the power of 5 minus 1. So that's 4 equals to 4 times the third term. So our third term will be AR squared. Now what we can do, we can divide both sides with AR squared. So we have AR raised to the power of 4 divided by AR squared. This will be equals to 4 times AR squared divided by AR squared. So AR squared, and AR squared will get cancelled from both sides, and this is going to leave us with a value R squared equals to 4. So R will be equals to plus or minus 2. So we have the common ratio. So using this, we can find out the value of our first term. So here, A, if we take A as the common factor, so we have A times 1 plus R equals to -4, or A is equals to -4 divided by 1 plus R. So let's use the two R values that we have obtained. So when our common ratio R is positive 2, in that case, our A value will be equals to -4 divided by 1 plus 2. So that's 3. So -4 third. And the other case, when our R value is equals to -2, so this implies that our first term will be -4 divided by 1 minus 2. So that's a -1. So -4 divided by -1 is going to give us a positive 4 value. So our geometric progression will be given by A, the first term, followed by AR, then AR squared, AR cubed. So these is going to be the geometric progression. So that means our value will be, our first term is -4 third. So we're considering this particular case, -4 third. This is our first term. So -4 third multiplied to 2, so that will be -8 thirds. Then we have -8 thirds multiplied to +2, so that will be -16 over 3, then -32 over 3. So this is geometric progression. Then the next one will be when we consider our A value is +4 and R is -2. Then we have 4. Then 4 times -2 will be -8. -8 times -2 will be +16, -32. So this is also going to be in geometric progression. So now that we have obtained the geometric progression, so let's obtain the sum as well. So we will use the formula that the sum is given by A times R raised to the power of n minus 1 divided by R minus 1. Sum up to n terms of a given geometric progression. Then this sum, which has a first term of -4 over 3 and a common ratio of +2, then our sum up to n terms will be equals to -4 over 3 whole raised to the power of 2 raised to the power, since I've taken positive common ratio, n minus 1 divided by 2 minus 1, so that's simply +1. And for this particular GP, then our sum up to the nth term will be the first term multiplied to the common ratio, which is -2 raised to the power of n minus 1, whole divided by, so -2 minus 1 will be -3. In this case, this will be -4 third whole multiplied to -2 raised to the power of n minus 1. So we have obtained two sums. So let's note them. So whenever our first term is given by -4 thirds, the common ratio is positive, then the sum up to the n terms will be -4 over 3 whole multiplied to 2 raised to the power of n minus 1. And this corresponds to this particular geometric progression. Then the other case will be when our first term a value is 4 and the common ratio is -2, in that case the sum up to the nth term will be -4 thirds whole multiplied to -2 raised to the power of n minus 1, and this corresponds to this particular geometric progression.